Yeah, this is another LP model. The previous one we did, it's called multi-location, not multi-period. So multi-location were similar to the one we did where you produce a certain product but in different locations or using different machines like we just did. This one is a multi-period. You can produce your product but in different times. Yeah, they also call it blending. Yeah. This company, they do baseball and footballs for the next 3 weeks. But in each week, there is certain demand. So if they do a baseball week 1, the demand is like they gotta have 800. If they do a baseball week 2, demand is 1,000. And they give you all the different demands. They also tell you that a baseball costs $5 and a football costs $7.5 and $2 to store. So you have the option of storing in inventory your product. Now, in order to do this, they also call this production inventory. So we start the process by, like we always do, defining all the different variables. And I believe there was something like this in the assignment. So you go, let B1 be number of baseballs produced week 1. B2 produced week 2. B3 produced week 3. And then we have F1, F2, F3. That would be footballs produced in 1, 2, 3. But now, in addition to this, I probably, instead of doing this, I should have said BP1, P1, P3, and same here. Because not only you can produce, you can store. So for the same 6 variables, I'm gonna change from BP1 or FP2, FP3 to I or S, doesn't matter. So I, PI, PI3, 1, 2, 3. So these are a number of stores stored in inventory. Week 1, 2, 3. So now, you can store, you can produce. So altogether, there are 12 different variables. After you define all of them, so remember, the BI1, that's baseball, stored, inventory, week 1. FP1, football, produced, week 1. So after we do this, we can, first of all, we need to know whether it's a maximum or a minimum problem. So they want to minimize production and storage cost. So they tell you it's gonna cost $5 and it's the same whether you do it in 1, 2, 3. Sometimes, like the one you had in the assignment, each period has a different cost, but here they all have the same cost. So you go, I'm gonna minimize cost. It's $5 to produce a baseball week 1, week 2, week 3. It's 7.5 to do a football week 1, 2, 3. It's $2 to store a baseball week 1, 2, 3. It's $2 to store a football 1, 2, 3. Now, after you do this, we get to the subject 2. Subject 2 you can have a maximum of 5,000 a week. Can store a maximum of 5,000 a week. So whatever you put in inventory a week, so in week 1, you can put a baseball or a football. That's week 1. But the maximum 5,000. You gotta do this for each week. For week 2, because they tell you a week, you can store a baseball in week 2, you can store a football in week 2, maximum 5,000. You can store a baseball, football, 5,000. You currently have 400 baseballs, so here you have currently 400 stored and 450 stored for this one. And they tell you you also need to have 200 at the end of each at the end. Now, this is the only thing that makes this question different is how can you meet the demand for week? So let's do demand week 1. We'll do demand for week 1 baseball. They tell you in week 1 for baseball, you currently have 400. They tell you, you currently have 400. So you say, it's 400. I can produce some baseball. So you can add minus, I can store some of whatever I produced, but this should meet the demand of 800. This is for week 1. Now you go to week 2 to see how you can satisfy demand for week 2. You enter this week having some stored from the previous week. You can add production minus store some of what you did, and that should satisfy demand of 1,000. Week 3 baseball. You enter week 3 probably with some, sorry, this is minus stored. Okay, so you enter this week 2 with some stored from the previous week. You can add production minus, you can store some, and that should meet the demand of 1,000. Week 3, you enter the week with some stored. You can add production minus store some of what you did. And they tell you, you gotta have, let me see, you gotta have 200. So minus, you gotta have 200 at the end. So you say minus 200, and that should meet the demand of week 3. Let's do demand week 1 football. They tell you you have 450. You can produce some. You can store some of what you produced, and that should satisfy demand of 1,200. Week 2, week 3 football. You probably have some stored from the previous week. You add produce some minus you store some of what you produced must satisfy the 1,500. And finally, you enter this having some stored from the previous week. You add production, you store some, you gotta have 200 left, and must satisfy demand of 3,000. All variables greater than or equal 0. Now, at this point, we covered all the different ideas of LP model. What I want you to do, if you can write them all down, have them in front of you, plus write down the answers for the last assignment, because it's a major assignment. So we did all of them, so write them down, have them in front of you. You also need the feasible region question. I did one in this review, my first video. And plus, there were 2 from the previous assignments, so have them also in front of you. And there's only one concept left, and that's the sensitivity analysis. I'll do this in my last video.